Welcome to this explainer. So today we're looking at the blood-brain barrier. And even if you already know the basics of this essential system, diving into exactly how this biological marvel actually operates, well, it reveals a setup that is way more complex and, honestly, way more fascinating than just some simple security gate.
Okay, let's dive into this. I want you to take a second and really picture it in your mind's eye. When you hear the phrase blood-brain barrier, what exactly pops into your head?
Right? It's super easy to picture this literal fortress, like a massive brick wall or a heavy iron gate just wrapping right around the brain to protect it. But the reality of how your brain protects itself is a completely different kind of architecture. It's actually not a single physical barrier on the outside at all, not even close.
So here's the crucial point. The blood-brain barrier is actually a property of the tiny blood vessels that spread throughout your entire brain. I want to let that sink in for a second. Instead of a single wall on the outside, think of this massive, incredibly complex network of tiny blood vessels, capillaries, just woven deep into every single microscopic corner of the brain tissue itself. The barrier isn't just sitting on the surface, it's fundamentally a characteristic of the plumbing that exists everywhere inside the brain.
And because this barrier is woven throughout the entire brain like that, well, there's no single main entrance to guard. Instead, every single tiny capillary acts as its own highly selective checkpoint. The security isn't just stationed at the front door, it's literally actively patrolling every microscopic corridor in your head.
And this brilliantly illustrates that we aren't just talking about a few dozen checkpoints here. We are talking about millions, millions of them. It's this vast, decentralized security network that is constantly operating across your entire brain 24/7. At every single one of those millions of checkpoints, this ruthless, ongoing evaluation takes place. It's basically a two-step process. Step 1, evaluate the molecule traveling through the blood vessel. And step 2, make the call. It either allows that specific molecule to pass through into the delicate brain tissue, or it traps it right there in the bloodstream so it can be safely carried away. Now, this biological masterpiece creates a pretty fascinating paradox for us. Because this system is so unbelievably highly selective across all those millions of checkpoints, delivering drugs to the brain is actually one of the biggest challenges in modern neuroscience. Think about it. When we actually want something to get past the barrier, like a life-saving medicine, for example, this incredible natural defense suddenly becomes a massive hurdle. See, the barrier doesn't know the difference between a dangerous toxin and a helpful treatment. It just does its job flawlessly. Which really leaves us with a truly compelling mystery. If millions of perfect microscopic checkpoints are constantly working to keep things out, how will we ever get life-saving drugs inside? Understanding that the barrier is a massive, decentralized network rather than a wall, well, that's the very first step to solving that puzzle. Anyway, thanks for joining me for this explainer. I really hope it completely changes how you picture your brain's incredible defenses.